Hello guys, welcome to the next lecture on the PY questions of the numerical analysis. Today in this lecture we will cover about the fixed point iteration scheme. Myself Dr. Harish, I will cover all those questions from the GATE mathematics from this years. You can simply follow my YouTube channel where you can find the playlist of the GATE mathematics and you can see the various PY question series such as the power series, ordinary differential equation, double integration from the integral equation, numerical analysis, Gauss divergence theorem, Bessel's and the Lysander function, and many more, which is available in this playlist. You can simply follow it and learn many tricks for solving this problem. So let's start with this one. So before I give directly to the PYQ, I will tell you what is the fixed point method and what are the various shortcut tricks. So I will tell you the various shortcut tricks so that you can solve each question with the help of the 10 to 15 second time periods. So I hope you can like, share and comment on video after watching this complete video. Now, any of the point is said to be the fixed point if this equation satisfied, or if you have the function f of x is 0, for example, then if you draw the graph of, like, this is my fx, you can draw the straight line which passes to the origin and the point of the intersection of this fx and the line y is equal to x. So these 2 points are called as the fixed point. So if you are good at the graphical representation, you can simply draw the graph of the function of this, say, phi x, and then you can check whether it intersects at some point or not. For example, here you can I will tell you the simplest approach. Can 3 be the fixed point? Check whether 3 is a fixed point or not. You can substitute x equal to 3 here. If you get answer is again 3, then it is a fixed point, but you can see that it is not equal to 3. So it means 3 is not the fixed point. Can 2 is the fixed point of this problem? You can substitute here. It will be 2 plus 2 is a 2. Yes, it's a fixed point. Can x is equal to, say, minus 1 is the fixed point? You can substitute here is again minus 1. So x is minus 1, root 1 is minus 1 as well. So yes, this is a fixed point. So this is the way you can check about the fixed point. Can you find the fixed point of this? There is no fixed point of this problem, because if you take x equal to 3 is the fixed point, 3 plus 1 4, 4 is not equal to 3, so this is not a fixed point. Or if you draw the graph of the x plus y or x plus 1, and what is the graph of the x is equal to y, so you can see this is the graph of the parallel lines and will never intersect, so it means there is no fixed point of this problem. Now, once you know how you can identify the fixed point, you can check about the fixed point iteration. Any of the sequence, remember this is my sequence, any of the sequence which is generated by this formula, that is by using the fixed point iterations with initial guess as x naught, and it will help you to find the root of this f of x is 0. Now this method is basically helping to find the roots of the nonlinear function, that is f of x is my 0. It may be algebraic or it may be transcendental equations are there, but always remember, whenever you have the equation f of x is 0, you try to convert this equation into the fixed point form. But the question arises is how you can define this phi x. So first of all, there are so many methods. I will explain you a simple example. Can you find the value of the x from this case? I can easily find the value of the x from here is 2 minus x square of root 3. Or you can find the x from this also. So what is the x will be? It's a root of 2 minus x cube. Or you can find you can take x common from this case. So it is x square plus 1 is equal to 2, and x will be my 2 over x square plus 1, and many more are there. Fine. So there are so many ways you can find the value of the x by using this one. Now the question arises is how you can choose the suitable phi, and if you choose the phi, then what is the criteria for the convergence of the root, because this is the important concept. If you understand this concept, you will solve each PY question within a 10-second trick. Now how you can choose the phi x? A very simple approach is you can choose phi x such that whose derivative should be less than 1. If this condition met, then you can say the scheme or iterative method is my convergent. Fine. If this number is my strictly less than 1, then it is my convergent. On the other hand, if my greater than 1, then the process is my divergent. But what will happen if my say derivative is my 1, like of this? If derivative is my 1 for some x and for some other x it will be less than 1, then again the process is convergent, but the number of the iterations would be very large. On the other hand, if I consider phi of x is my very small, which is almost approaches to the 0, again it is a less than 1, so it means it's a convergent, but the number of the iterations will be very small. So this is the way you can check about which phi you can choose. The phi you can choose and such that phi dash should be less than 1. So once you know what is the phi is, you can find the value of the phi, and then the error bound you can define like here, where lambda is the maximum of the first derivative, where a and b are such that f of a is my less than 0, f of b is my greater than 0. What is the f is? The equation on which you have to find the root of the equation, and x naught is my initial point, that's the initial guess, and x1 is my first approximation point, which is obtained by this method. Now based on this simple tricks, I can solve each PY question in a simple manner. So let's start with the PY question. I hope you can like, share and comment on my video as well. You can join with me through my WhatsApp group. You can scan and join my group here. So let's start with the first question. What is the first question is, if this is my given, so that means f of x is my here. Fine. This has the root lies between 4 and 5. The fixed point equation, so phi of x is given to be half e raised to power x by 2. Then when it will be the convergent, we can find the derivative. So derivative will be 1 by 4 x by 2. Then I can start with the here. Fine. So what is that? I can choose any number between the 4 and 5. You can choose any number. Let's say I can choose 4.5. So what is the value of this 4.5? It is my 2.25. So clearly say e raised to power 2.25 divided by 4 is greater than 1. So what does it mean? It is my divergent. So once it's a divergent, A is my right answer of this problem. Look at the second question. The iterative scheme, this is convergent of this. Okay, firstly I will tell you the tips. So if I compare, this is my phi of x, fine. So I can say phi of x is my x over 2, 1 plus a over x square, or I can take it as here, so it will be x plus a over x. So now what is the convergence means? They are talking about the order of the convergence. So I will tell you the two different methods. The first method is, as usual, I can start from here. It is half 1 minus a over x square. Now you can see that x square is always positive. A converges to the root of this, so a is also my positive. X square is also positive. Ratio is also positive. So this number is always less than of the 1, and it is less than of half. So what does it mean? If I start from the modulus, it is also less than half. It means it is my convergent. Now what is the tips for you is, if the iterative method convergent, then the order of the convergence is linear always. The order of the convergence of the iteration method is linear always. So you can see A is my correct answer of this problem. This is the first method. You can solve like this manner. There is one more method that I can tell you here. What is the second method is, you can find the value of the fx firstly. Fine. Now since it converges to the root of a, so it means my function is x square minus a. Fine. Now find the derivative of the function. Fine. If you find the firstly root, what is the root is? Root of a. Now find the first derivative at the point of the root a. What is the value of this? It is my 2 root of a, which is non-zero always, because a is my non-zero. Fine. A converges to a root of a. So if a is my greater than 0, so it means a is my non-zero. So what is the rule of that? If f dash is my 0, for example, f double dash is 0 at some point, f triple dash is my non-zero. What does it mean is order is the non-zero derivative. Order is my non-zero derivative. If I say f dash of a is my 0, f double dash of a is my non-zero, then the order will be, because the second derivative is non-zero, order will be 2. Now look at that. In this case, the first derivative is my non-zero. So what is the order of the convergence? 1. So what does it mean? 1. 1 is my linear. So this is my right answer. So you can apply any of the method. Either you can take the function fx and you can get the order as a 1. Otherwise you can use as a fixed point iteration. Okay, look at this another one. The iterative scheme such that the suitable x naught will converge or not. Again, there are the two methods. I will tell you the first method. That's quite easy. You can check about the option. Like I can start from here. I can substitute this value this. Fine. So is it satisfied? You can check about 1.8. Is it satisfied? Not satisfied. It means it is not convergent to this point. We can check about here 1.6, 1.5, 16 minus 1.6. Is it satisfied? It is not satisfied. Is it 2 satisfied? We can check about this. It's a 16 minus 12 over 2. It's a 6. 16 minus 6, 10. 10 by 5, 2 is satisfied. Yes, it is convergent. Fine. So once it's convergent, it may definitely not convergent will be cancel out. So D is my right answer. Second method. How you can define the second method? I can take the limit. So this value I can take as a L. So it is 1 over 5, 16 minus 12 over L. So I can simplify this 5L square minus 16L plus 12 is my 0. So what is that? 60 and 10. So 5L square minus 10L minus 6L plus 12 is my 0. So factors are my 5L minus 6 and L minus 2 is 0. Fine. So roots are my 6 over 5 and here. So clearly say it is, because these are my finite limits. Fine. It means this method is my convergent. And it converges either to the 2 or 1.2. So only the 2 answer is given to you. So that's why again these 3 options are cancelled. Right option is my D is the right answer. Okay, look at this another one. An iterative method for finding the nth root of the positive number a. It means my fx is xn minus of a is given to be here. Then for what value of the n the iterative method failed to converge? Okay, what will happen if n is equal to 1? My function is x minus a, which is a linear. Fine. So once it's a linear, and you know this is the fixed point iteration method, it works only for the non-linear. So this is the only right answer. Otherwise, you can see phi of x. Phi of x is my here x plus a over x raised to power n minus 1. I can check about this phi dash x. What is the phi dash x is? Half 1. I can take this number as 1 minus n in the upside. So it will be a 1 minus n divided by x raised to power n. Fine. Now you can take about this modulus. It will be half 1 plus a, 1 minus x raised to power n. Now clearly say when you take n is my 2, this value will be my negative. Fine. So 1 minus negative is always less than of the 1. So it is a convergent. When n is equal to 8, again this number is my negative. So again it is less than 1, because this number is x raised to power 8. This number is my 3, again negative. So again convergent. This is convergent. Only number is my a, which is not convergent, is the right answer. Although you may think about that when you take n is equal to 1, So this expression becomes my half of 1, which is less than 1. So you may think it is a convergent, but remember, when n is equal to 1, your function will be here. Fine. When your function will be this, then what is my phi x? So remember, when n is equal to 1, your phi x will be half x plus a, and clearly say this is my divergent sequence. Fine. Because if you think about the sequence, it is just like say n over a over 2. This is a sequence and it is a divergent sequence. So once it is a divergent, it is my fail to converge. So A is my right answer. Look at this another one. Consider the equative scheme here and which of the following sequence are. You may think about that this question can be solved by using the real analysis, but you may think about this problem is also solved by fixed point equation. Now it convergent or not. I can start from the limit. I can take L over 2, 3 over L. So what is that? It's a L over 2 is 3 over L. So L will be my plus minus root 6. So what is the concept is, it converges to the plus root 6 or it converges to the minus root 6. That depending upon, yes, that depending upon the value of the x naught. If x naught is my positive, then it converges to the positive limit. If x naught is my less than 0, then it convergent to the negative limit. Now look at that. X naught is my positive, so that means it is convergent. Now you can see the limits are my finite, so it means the last option is cancelled out. It does not converge because the limits are finite, so it converges always. Now x naught is my positive, so it means it converges to the positive limits. Now you can check. It converges only for x greater than 1. That's wrong, because whatever the value of the x naught greater than 0, if I take x naught is my 0.3 is a positive, then it converts the positive. It converges only when x naught is less than 3. Wrong, because if x naught I can choose as a 7, then again it is convergent because it satisfies this property. Again it converges to this. It convergent for any x naught is my positive is the right answer of this problem. Okay, h is a twice differentiable function on the 1, 2 with a fixed point alpha. Then the sequence converges quadratically. Very simple. Okay, if I say this is my given condition, fine, then the sequence converges quadratically. That means order is 2. Fine. So as I told you, if order is 2, it means the first derivative at the fixed point alpha should be 0, but it's a 2, then the second derivative should be non-zero. That's the condition. So h dash here, instead of the phi is a h. That means h dash of alpha will be 0. H double dash of alpha should be non-zero. He said h dash is a 0. Non-zero is a non-zero, but we need a 0. This is non-zero, is a 0, fine, and second derivative is a non-zero, is my correct answer of the problem. Given that x naught is sufficiently close to this, which of the following sequence will converge the fixed point? We can check firstly whether 3 will satisfy it or not. We can see about the last option. 9 minus 3 over 2, 6 satisfied. 3 is equal to 3 over 3 minus 2 satisfied. 3 is equal to 3 plus 6, 3 satisfied. 3 is equal to minus 6 plus 18 plus 1, it's a 19, 3, all are satisfied. Fine. If none of them is, if any option is not satisfied, we can discard that option. Anyhow, it convergent. What is the condition for the convergent? Phi dash at the point 3 should be less than 1. So this is my phi. Fine. So what is the derivative of this phi? 6 minus 3 over x square. What is the derivative at the point 3? It will be 6 minus 1 over 3, which is greater than 1. It means this is my divergent. So first option is cancelled out. Look about the second option. What is the derivative of this is? x over, sorry, what is the derivative of this? It is half, and 3 plus 2xn into 2, it is less than, so it will be 1 over 3 plus 2xn. So at that 3, what is the value of this? It is 1 over 3, which is less than 1. So yes, this is the correct option. What is the derivative of the third option? Is minus 3 over xn minus 2 square. So what is the derivative at the point 3 modulus? It is 3, 3 minus 1, 3 minus 2, 1, 1 square, which is greater than 1. This option is cancelled out. Look at the last option. What is the derivative of this function? It's a x, and derivative of this is my 3, which is greater than 1. This option is also cancelled. B is my right answer. Always remember, whenever there is a fixed point is given to you and convergent condition happen, this one. I hope you can like, share and comment on the video as well. If phi is the 3 times continuously differentiable, it equates this sequence convergence to the fixed point. The fixed point is given to be xi. The order of the convergence is my 3. Fine. What does it mean? Phi is my order of convergence is 3. That means the third derivative is my non-zero. And what about the first derivative? Should be 0. Second derivative should be 0. Fine. That only the third order is my 3. So first derivative 0, second derivative 0. Correct answer. First derivative non-zero. Wrong answer. First is greater than 0. Fine. But second is a non-zero. Wrong answer. Both are non-zero. Wrong answer. A is my correct answer. And you can see hardly 10 to 15 seconds you are needed to think the problem. Okay, for the fixed point, again the fixed point is there. Which of the following is there? Okay, I will tell you the two different methods. The first method, as I told you earlier, you can pick about it converges to the 2. Fine. So the first case is, this is my case. I substitute this g is my here. Check whether 2 satisfied or not. So 2 is equal to 1 plus 2 over 2 satisfied. It means this is the right answer. For this case, x is my 2 plus x is convergence to the 2. Is it satisfied? You can see again, 2 is 2 plus 2 satisfied. Yes, it is satisfied. So both P and Q are my right answer. There is one more method. What is the second method is? You can find the limits. Fine. If I say x is my 1 plus 2 over x, so I can take limit is L, which is 1 plus 2 over L. So L square minus L minus 2 is equal to 0. L minus 2, L plus 1 is equal to 0. L is equal to my 2 and L is equal to minus 1. So it means it converges to either 2 or minus 2. Now look at the x naught. What is my x naught is? Positive number. Once x naught is my positive, so it converges to the positive limit. So positive limit is my 2. Yes, it's a correct answer. Similarly, if you look about the second option, I can take x is my 2 plus x. I can take the limit L and then scaling them. So again, it will be same of this limit. You can see it's the same one. So L will be my 2, L will be my minus 1. And you can see again, x naught is my greater than or equal to 0. That means a positive number. Once is a positive, then it converges to the positive limit. That's a 2 is there. So both are my correct answer of this problem. So you can apply either of the method, but the first method is quite easy. You can substitute this value and check whether it's satisfied or not. Okay, look at this another one. Again, the fixed point is given to you. X is my 3 plus x minus 3 whole cube. The initial point is given to my here, the order of the convergence. So you are basically find the order of the convergence. So it means we have to find the nth derivative at some point is a non-zero, and that n is my order. Fine. It is similar to just like of this one, but the only difference is in this case the point is given at which we have to find the fixed point. Now can you find the fixed point of this? What is the definition of fixed point? Can you find any x which satisfied this equation? Clearly say x is equal to 3 will satisfy it, because 3 minus 3 is 0, x is equal to 3. So 3 will the fixed point. Now that's over. What is my phi of x? Because we need a phi. Phi is my here. Fine. Now you can find the derivative of this x. It is my 3x minus 3 square. So clearly say phi dash of 3 is my 0. So it means 1 is not the order. What is the phi double dash of x? It is 6x minus 3. Again you clearly say phi double dash of 3 is my 0. So 2 is my not a fixed point. 2 is not the order because we need a non-zero. What is the third derivative of this x? Is my 6, and clearly say third derivative is my 6, which is non-zero. So 3 is my fixed, or third is my order of this fixed point equation. Look at this one. A real sequence generated by the iterative scheme. Again, make sure this question can be solved by real analysis as well as the numerical methods. So they are talking about the convergent or divergent. I can simply take the limit L. So this is L, this is L by 2 plus 1 over L. What is the L is? Always remember it's a limit n approaches infinity of xn. Fine. I can take the limit n approaches infinity in this case. So now is a L over 2 is my 1 over L. So what is the L? L is my plus minus root 2. Now is it convergence to the plus root 2 or minus? We will see it. So since this is my finite limit, so it means it is a convergent. So this option is cancelled. Collection of all those x naught apart from the r and r minus 0. So it means if I take x naught is my minus 3, which is less than 0, then this sequence will converge to the minus of root 2, but he said plus root 2. So this option is cancelled out. If x naught will be here, so clearly say this option will be greater than 0. So if x naught is my positive, then it converges to the plus of root 2, and yes, this is the right option. Collection of all those x naught apart from the 0. If I choose x naught is my 0.5 in this interval, then it converges to the plus root 2. But if I choose x naught is my minus root 5, which is my less than 0, then it converges to the minus root 2. But he said always convergent to the plus root 2 is the wrong answer. Correct answer is only B is my here. Look at this another one. Let x naught will be here, then define this sequence for every, then it's increasing, decreasing or not. I think it's again a very simple. How you can solve out this? So basically this is my x is equal to cos x. Fine. I think that's a simple. If I draw the graph of the cos x, it will be cos 0 is 1. Fine. So it will be like of this. Fine. And if I draw the y is equal to x, so clearly say this point and this point is my fixed point. Fine. So once you get the fixed point, it will be convergent. Clear? Once you get the fixed point, so definitely it will be my convergent. So it is not convergent, cancel out. Now, is it increasing, it's a decreasing, or it's a convergent? How you can check about the increasing and decreasing? Okay, n is greater than 0, x0 is my 0. So what is my x1? x1 is x0, cos 0 is my 1. What is my x0 is my 0. x2 will be my cos of 1, and its value will be lies between minus 1 to plus 1. So you can see that it is increases, and then it can be any value in between them. It's a firstly increase, then decrease. So it is increasing always, cancel out. It is decreasing always, cancel out. It is increasing and the limit is lies between even and odd. That's a fine, because either it's a increasing or a decreasing. So that means C is my right answer of the problem. the number of the roots of the equation in this interval. Again, a very simple, because we are finding the number of the roots. It means either we can apply the bisection method, either we can apply the regular falsy method, either we can apply the fixed point equation method, or you can apply either as a Newton-Raphson method. But there is no need, I can simply apply the fixed point. Can you draw the graph of this? This is my y is equal to x square. Fine. I can written this x square is equal to cos x. It is just like say, or I can written x is my, so you can see it is nothing but my phi of x. Fine. Can you draw the graph of the cos x? Cos x will be my here. Fine. Now, in this interval minus pi by 2, where is the minus pi by 2? What is the cos pi by 2? 0. So, this is the value of the pi by 2, and this is the value of the minus pi by 2. In this interval, how many points of the intersection appears? You can see you will get as a two fixed points, and we all know what is a fixed point. Fixed point is the solution of the equation. That means they are the roots of the equation f of x is my 0. So once you get the 2, so you will get as the answer as my 2 is the required answer. So you can see that within a very less time period you can solve each questions in a very simple manner. I hope you can like, subscribe and comment on my video as well. Look at this another one. F is a twice continuously differentiable method. The order of convergence of the secant method. Order of convergence of the secant method. We all know it's a 1.618. And if you calculate this, the right answer is A is the right answer. I will tell you the different methods have the order of convergence. Bisection method has always one, that's a linear convergence. Regular falsy has a rate of order of convergence 1. Secant method has the rate of convergence, order of convergence is my 1.618. Fixed point equation method has the rate of convergence 1, and Newton-Raphson method has the rate of convergence 2. That means you can see these are my order of the convergence. So what does it mean? 1 means that's a linear, 2 means that's a quadratic, 1.68 means it is faster than of the linear but slower than of the quadratic. So the right answer is A is my right answer of this problem. So I hope you can learn many tricks while solving the problem. In the next lecture we will see how you can solve the PY question of the Newton-Raphson method again from the GATE examination. Till then you can simply like, share and comment on my video. Best of luck students. Happy learning.